30 million years before Tyrannosaurus Rex ever existed, something else ruled the floodplains of what is now North Africa. Something longer, something stranger, something that, for nearly a century, sat almost forgotten in the back rooms of a German museum, until the building it was kept in was destroyed, and the only direct evidence of its existence vanished in a single night. What survived were the notes, the drawings, the measurements taken by a paleontologist who knew, even as he described it, that he had found something that didn't fit the rules. Because this animal wasn't built like a typical apex predator. It had a sail on its back taller than a grown man, jaws shaped more like a crocodile's than a Tyrannosaurus, and evidence, still debated today, that it may have spent much of its life doing something almost no large predatory dinosaur is thought to have done: hunting in water. This is the story of Spinosaurus, the animal that may have been the largest predatory dinosaur that ever lived, larger even than Tyrannosaurus Rex, and the story of how we lost it, found it again, and are still, right now, trying to understand what it actually was. I'm Nathan Wild. Few mysteries in paleontology have unraveled and rewritten themselves as dramatically as this one. Today, we're reconstructing not just an animal, but the strange, broken history of how science came to understand it at all. The story begins in 1912, in the Bahariya oasis of the Egyptian desert. German paleontologist Ernst Stromer von Reichenbach, working with local fossil hunters, uncovered a partial skeleton unlike anything previously documented. Vertebrae with neural spines extending more than 1.5 meters above the spine.
A long, narrow snout lined with conical teeth, completely unlike the blade-like teeth of other large theropods. Stromer named it Spinosaurus aegyptiacus, the spined lizard of Egypt, and published his findings in 1915, in the middle of the First World War. The fossils were transported to the Bavarian State Collection for Paleontology in Munich, where they became one of the museum's centerpiece exhibits. And then, in April 1944, Allied bombing raids destroyed the museum building. The Spinosaurus holotype, the original specimen upon which the entire species was scientifically defined, was obliterated. For decades, paleontologists had nothing to work with except Stromer's original papers, his sketches, and a handful of photographs. An entire species known to science for less than 30 years, reduced to paper and memory. For the rest of the 20th century, Spinosaurus existed in a strange scientific limbo. Paleontologists knew it had existed. They knew roughly what its spine looked like, but without the actual bones, reconstructing its full anatomy, its proportions, its way of life, all of it was guesswork built on fragmentary historical documentation. Then, beginning in the early 2000s, new Spinosaurus material started appearing, fragments recovered from Moroccan fossil deposits in the Kem region, sold through commercial fossil dealers, scattered across private and institutional collections around the world. Paleontologist Nizar Ibrahim, working with a Moroccan fossil collector, eventually tracked down critical specimens and assembled what became the most complete Spinosaurus skeleton reconstruction to date, published in 2014.
Every detail pointed in the same direction. This was not a typical land-hunting theropod. This was an animal built, in some significant way, for life in and around water. The aquatic Spinosaurus hypothesis is one of the most contested debates in modern paleontology, and I think it's worth walking through both sides carefully, because the disagreement itself tells us something important about how science actually works. The case for a heavily aquatic, even semi-submerged Spinosaurus rests on several converging lines of evidence. The dense, less pneumatic bone structure mirrors that of modern animals that spend significant time in water. Think of how a hippopotamus or a penguin has denser bones than a fully terrestrial mammal of similar size, an adaptation that helps control buoyancy. The tail, reconstructed by Ibrahim's team in 2020, showed unusually long neural spines and chevrons, creating a flexible, fin-like structure that computational fluid dynamics modeling suggested could generate effective thrust underwater.
Add to that the conical, interlocking teeth, better suited for gripping slippery prey like fish than slicing through flesh, and isotopic analysis of Spinosaurus teeth, published by researchers including Romain Amiot, showing oxygen isotope ratios more consistent with semi-aquatic animals like turtles and crocodilians than with fully terrestrial theropods. The evidence, taken together, paints a picture of an animal deeply tied to aquatic environments. But not every paleontologist agrees with how far that picture should be pushed. If you're finding this investigation as compelling as I am, join me for more expeditions into prehistoric life. Every week, I follow the fossil evidence wherever it leads. Subscribe and don't miss what's coming. A significant body of research, including work by paleontologists Donald Henderson and Thomas Holtz, has challenged the most extreme version of the aquatic hypothesis, particularly the idea, briefly proposed, that Spinosaurus was so adapted to water that it could barely move efficiently on land at all. Henderson's buoyancy modeling, published in 2018, suggested that the proportions reconstructed by Ibrahim's team would have made Spinosaurus dangerously unstable in water, prone to tipping over rather than swimming efficiently. Critics also point out that the 2014 reconstruction combined bones from multiple individuals of potentially different sizes, raising legitimate questions about how reliable the resulting proportions actually are. The more recent position, and the one with growing support, is something in between the extremes. Spinosaurus likely was not a deep-diving aquatic pursuit predator chasing fish through open water like a prehistoric crocodile.
But it almost certainly was an animal heavily adapted for life at the water's edge, wading through shallow rivers and lagoons, using its long jaws and conical teeth to snatch fish and other aquatic prey, in a manner more comparable to a modern heron or a grizzly bear fishing in a stream than to a swimming predator. This middle position is in many ways more interesting than either extreme. It suggests an animal occupying an ecological niche essentially unprecedented among large theropod dinosaurs, neither a typical land hunter nor a fully aquatic predator, but something genuinely in between, exploiting a resource, the enormous fish populations of Cretaceous North African river systems that few other predators were equipped to access. And those fish were not small. The Kem River system, where Spinosaurus lived roughly 95 million years ago, supported an extraordinary concentration of giant fish. Alcopristis, a sawfish relative with a rostrum lined with backward curving teeth, could reach lengths exceeding 7 meters. Coelacanths far larger than any living today swam these waters. Lungfish the size of a grown man have been recovered from the same deposits. This ecosystem, sometimes called one of the most dangerous places in the history of life on Earth, also hosted multiple other enormous predators simultaneously: Carcharodontosaurus, a theropod rivaling Tyrannosaurus in size, and Deltadromeus, another large carnivore, all coexisting in the same region during the same geological period. That detail genuinely surprises most people when they first hear it. Multiple apex-sized predators, all enormous, all theoretically competing for resources in the same place at the same time?
The answer researchers increasingly favor is niche partitioning, and Spinosaurus may be the most dramatic example of it ever discovered. While Carcharodontosaurus hunted large terrestrial prey on land, Spinosaurus may have specialized almost entirely in the aquatic food web, allowing both giants to coexist without directly competing for the same resources. In terms of pure size, the 2014 reconstruction estimated Spinosaurus at roughly 15 meters in length, making it, by length at least, longer than any known Tyrannosaurus Rex specimen, and a serious contender for the largest predatory dinosaur ever to walk the Earth. Mass estimates are more contested given the uncertainty in body proportions, but even conservative figures place it among the largest theropods known to science. What I find genuinely moving about this animal is not just its scale, it's the fragility of what we know about it. An entire species lost once to war and rediscovered piece by piece over decades, assembled from bones scattered across multiple countries and collections, its lifestyle still actively debated by serious researchers using cutting-edge biomechanical modeling. We are, quite literally, still discovering what Spinosaurus was in real time as new fossils continue to emerge from Morocco and as new analytical techniques continue to refine the picture. Few extinct animals demonstrate so clearly that paleontology is not a finished body of facts, but an active, ongoing investigation. So, was Spinosaurus the king before the king? In terms of raw length? Quite possibly.
In terms of ecological dominance, the picture is more nuanced. Spinosaurus may never have needed to compete directly with the great terrestrial predators of its world because it had carved out something rarer, an entire kingdom of its own, in the rivers and shallows where almost nothing else its size could follow. That, to me, is the most extraordinary part of this story. Not that Spinosaurus might have been bigger than Tyrannosaurus, but that it solved the problem of being a giant predator in a completely different way, not by dominating the land, but by claiming the water that nothing else dared to fully exploit. A king that ruled a kingdom most predators of its size never even tried to enter. If Spinosaurus has shown you how much our understanding of even the largest dinosaurs can change with new evidence, the next investigation takes us to the predator that came after, to Tyrannosaurus Rex itself, and to the growing scientific case that this animal was far more intelligent and socially complex than anyone imagined. What was it really like to think like the apex predator that finally inherited the crown? I'll see you there.